Welcome back. In this lecture, we will talk about programs and programming languages. So here is our outline. We will see what are programs and programming languages. We will talk about the machine language, the assembly language, and high-level languages. So first of all, let's define a computer, and is also called a software. It is basically a set of instructions that tell a computer what to do. We use programs to interact or talk with computers. In order to tell computer to do something, we should use program. To write programs, we use programming languages. Let's talk about programming languages. Basically, there are languages that are used to write programs. As you know, computers are machines. They do not understand human language. Programs are written in language that a computer can understand, which is a programming language. So to be able to interact with computer, we should write programs using a language that computer can understand, which is a programming language. Now let's see what do we mean by machine language. This is the computer's native language. It is the main language of a computer, and this language uses zeros and ones. So the digit 0 and the digit 1, and this is why it is called the binary language. Binary means two things. So as you can see, there are two digits, the 0 and the 1. For example, if we want to add two numbers, 2 and 3, we will write something like this. This is the instruction written using the machine language. It is a group of ones and zeros, as you can see. And this is only one instruction just to get the sum of 2 and 3 and get the answer, which is 5. So as you see, it is very hard to use. Moreover, machine language is machine dependent. It differs among different types of machines. So the code over here might work on a certain machine and it might not work on another machine. So this is what we mean by machine dependent. Let me tell you this. Every instruction should be written in machine language before it can be executed. Later on, we are going to write programs using Java, so the instructions will be written using the Java programming language. So all those instructions must be translated to machine code before we can execute them, and this applies to all other programming languages. Now let's talk about assembly language. It was developed to make programming easier. First of all, it is also machine dependent, and in the assembly language, keyword was introduced. For example, we have a keyword add and a keyword sub and a lot more, so programming was a little bit easier. For example, if you want to add 2 and 3 and get the result, we will write something like this. This is the assembly instruction. We are telling the computer to add the number 2 and the number 3 and to store the result somewhere called a result. So this is an instruction written in the assembly programming language. So this cannot be executed because, as we said, all instructions should be written in machine code before we execute them. There is a program called assembler that translates assembly code to machine code. Let's talk about assembler. Suppose that we have an assembly code over here. As we said, it cannot be executed. So this code is given to the assembler, and the assembler translates this code to machine code. And now this code over here can be executed. And this is how we can execute assembly code. So whenever we write programs using assembly, we will translate it to machine code and using the assembler, and then we will execute it. Now let's talk about high-level language. High-level languages are a new generation of computer languages. In a high-level programming language, we use English words. This is why a high-level programming language is easy to learn and easy to use. Also, high-level programming languages are machine independent, and our program will run on different machines, and this is very important. And each instruction written in high-level programming language is called a statement. Okay, and so later on, whenever we write an instruction using Java, for example, we will call it a statement. And a program written using a high-level programming language is called a source of program or source code. Now let's see this example. If we want to add 2 and 3 and get the result, we would do something like this in Java. This is an instruction written using a high-level programming language. This is the statement and is very similar to mathematics, right? We are saying that we want to store inside the results the answer of 2 plus 3. 2 plus 3 will be calculated as 5, and 5 will be stored in a variable called result. In mathematics, we have concepts of variable, and also in programming, we have variable. If you don't know what is variable, no problem. I'm going to explain it from scratch. But for now, look at this expression and see how much it's easier than assembly and machine code. And look at this semicolon over here. Basically, every instruction or every statement should end with a semicolon, and you will see this later on. Now, just like before, this is a statement written using a high-level programming language, so it cannot be executed, and we should translate it to machine code, and then we can execute it. We can use what's called a compiler or an interpreter in order to translate a source code to machine code. And remember, source code is a program written using a high-level programming language. So, for example, this statement over here is a source code because it is written in our high-level language. So let's see how we can translate this statement to machine code using a compiler. Basically, a compiler translates all source codes into machine code. We have a source program or a source code. We will use a compiler to get an executable. An executable is a file that can be executed by our computer. Let's have a look. We have the source code over here, and we use the compiler to generate the machine code. We can execute it using the executor to see the output or the result. So the compiler converts all the source code or all the program to machine code, and then we can execute it to see the output. Now let's look at the interpreter. An interpreter translates each statement into machine code and execute them right away. So it will not translate all the program. It translates each statement at a time. And we have something like this. We have a statement from program. The interpreter will translate it to machine code, and then it will execute it, so we will see the output. And this over here will be done on all the statements and our program statement by statement, but the compiler translates all of the program into machine code. Okay, so this is the difference between the interpreter and a compiler. the interpreter and compiler.